In this video of this CompTIA Network Plus, we are going to cover part 1.4, Objectives, explain common networking ports, protocols, services and traffic types. So let's get into it. In networking, protocols and their associated port numbers define how devices communicate over a network. Each protocol serves a specific function, ensuring data is transmitted efficiently and securely. So let's explore some of the most essential networking protocols and the ports they use, and which you need to know also for your CompTIA Network Plus exam. File Transfer Protocol, or FTP, operates on ports 20 and 21 and is one of the oldest and most widely used method for transferring files between computers. Port 21 is responsible for handling the control commands between the client and the server, while port 20 is used for the actual data transfer. While FTP is effective, it doesn't encrypt data, making it vulnerable to interception. And to address these security concerns, the Secure File Transfer Protocol, or SFTP, was introduced. SFTP operates on port 22 and uses the Secure Shell, or SSH, protocol to encrypt file transfers, ensuring data is protected from unauthorized access. SSH itself, which also runs on port 22, is used to securely access remote devices over a network, replacing older and less secure remote access methods like Telnet. Telnet, which operates on port 23, provides a way to access remote devices using a command line interface. However, it does not encrypt data, which means that credentials and commands are sent in plain text, making it a security risk. As a result, SSH is preferred alternative for secure remote access. For email communication, the Simple Mail Transfer Protocol, or SMTP, is used to send messages between mail servers. SMTP typically operates on port 25 for standard email transfers. However, to enhance security, SMTP-S, which encrypts email traffic, runs on port 587 or 587. And the Domain Name System, or DNS, is critical protocol that translates human-friendly domain names into IP addresses. Without DNS, users would have to remember complex numeric IP addresses instead of website names. DNS typically uses port 53 for both query requests and responses. And the Dynamic Host Configuration Protocol, or DHCP, automates the assignment of IP addresses to devices on a network. When a device connects to a network, it sends request on port 67 and the DHCP server responds on port 68, assigning an IP address dynamically. This eliminates the need for manual IP address configuration. For simpler transfers where security is not a primary concern, Trivial File Transfer Protocol, or TFTP, is an alternative to FTP, or File Transfer Protocol. And TFTP operates on port 69 and is used in scenarios such as transferring configuration files to network devices. And when you browse the web, the Hypertransfer Protocol, or HTTP, is responsible for loading websites. HTTP operates on port 80 and facilitates communication between web browsers and servers. However, HTTP transmits data in plain text, meaning it is not encrypted, which led to the introduction of HTTPS protocol. Hypertransfer Protocol Secure, or HTTPS, runs on port 443 and encrypts web traffic using SSL/TLS, providing secure communication for websites handling sensitive information such as passwords and payment details. The Network Time Protocol, or NTP, is used to synchronize clocks across devices in a network. Accurate timekeeping is crucial for security, logging, and scheduling tasks, and NTP operates on port 123 to ensure all systems maintain accurate timestamps. For network monitoring and management, Simple Network Management Protocol, or SNMP, is widely used. It runs on port 161 and 162 and enables administrators to collect and manage data from network devices such as routers, switches, and servers. Lightweight Directory Access Protocol, or LDAP, is used for accessing and managing directory information services, such as user authentication and organizational directories. LDAP typically operates on port 389, while its encrypted version LDAP-S runs on port 636 to provide secure authentication and data access. Next one is Server Message Block, or SMB, which facilitates file and printer sharing between devices in a network. This protocol is commonly used in Windows environments and operates on port 445. Syslog is a protocol used for logging system messages and collecting event logs from network devices. It runs on port 514 and helps administrators monitor network events and troubleshoot issues effectively. Now let's shift our focus on fundamental types of network traffic. And network traffic can be classified based on how data is transmitted from a source to its destination. The most common type is unicast, where data is sent from one device to a specific destination device. For example, when you access a website, your computer sends a unicast request to the web server, which responds with the requested web page. Multicast, on the other hand, involves the sending data to multiple recipients who are part of a specific group. Streaming services and online gaming often use multicast to efficiently deliver data to multiple users at once without sending separate copies to each recipient. Anycast is a routing technique where multiple servers share the same IP address, and the closest server to the requester responds. This method is commonly used in content delivery networks or CDNs to optimize performance and reduce latency. Broadcast traffic is sent to all devices within a network segment. A common example for broadcasting is DHCP, where a newly connected device sends broadcast requests to locate a DHCP server. To facilitate network communication, several essential protocols define how data is transmitted. The Internet Protocol, or IP, is the foundation of network communication, allowing devices to send and receive data across networks. With IP, there are various supporting protocols. The Internet Control Message Protocol, or ICMP, is used for sending diagnostic messages, such as responses generated when using the ping command to check network connectivity. Transmission Control Protocol, or TCP, is connection-oriented protocol that ensures reliable data delivery. It establishes a connection between transmitting data, verifies that all packets arrive in order, and transmits any lost packets. This makes TCP ideal for applications such as web browsing, email, and file transfers. In contrast to TCP, a User Datagram Protocol, or UDP, is a connectionless protocol that sends data without establishing a session. While UDP is faster than TCP, it does not guarantee packet delivery, making it suitable for applications that prioritize speed over reliability, such as video streaming and online gaming. Generic Routing Encapsulation, or GRE, is used to encapsulate packets for transmission over different network protocols, allowing for secure communication between remote sites. Internet Protocol Security, or IPsec, is a suite of protocols designed to secure network communications. IPsec includes the authentication header, or AH, which provides authentication and integrity for packets, and the encapsulating security payload, or ESP, which encrypts data for confidentiality. The Internet Key Exchange, or IKE, is used to establish and manage security association between devices. Each of these protocols plays a crucial role in ensuring secure, efficient, and reliable communication across networks. Understanding them is essential for any networking professional to configure and troubleshoot network environments effectively.